Good morning, everyone. I am Assistant Professor K.C. Panigrai. Welcome you all on behalf of Roland Institute of Pharmaceutical Sciences to this AICTE-sponsored STTP. Let us begin our scientific session with a virtual lamp lighting.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तु ते दीपज्योतिर्नमोऽस्तु ते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
It's a great privilege to welcome our speaker of this STTP program, Professor Pratap sir. So may I request our principal sir to formally welcome our speaker of this STTP, Professor Pratap Mohanty sir.
Good morning, all. Namaste, Professor Pratap sir. It is a privilege to have you today on our program. On behalf of the management and staff, students of Roland Institute of Pharmaceutical Sciences, I would like to invite you to this AICTE-sponsored short-term training program, sir. I hope that your lecture will definitely benefit all of us. Thank you very much, sir. And I request Dr. Gautam Jana to introduce Professor Pratap Mohanty, sir, to the delegates.
Thank you, sir, for giving me the opportunity to introduce the speaker of that particular session, Professor Pratap Kumar Mohanty. I, Dr. Gautam Kumar Jana, Associate Professor, Roland Institute of Pharmaceutical Sciences, feel privileged to introduce Professor Pratap Kumar Mohanty, sir, the speaker of that particular session. Professor Pratap Kumar Mohanty is currently working as Professor, Department of Marine Science, Berhampur University. He has total 33 years of academic experience. He was awarded PhD from Indian Institute of Technology, Delhi. He has completed the Commonwealth Fellow, United Kingdom at University of Reading, UK. He was the former head and Dean of Faculty, Science and Technology, Berhampur University. He was the member and chaired in different offices of Berhampur University. He was the member of Senate and Syndicate of Berhampur University. He has already served as Director, International Collaboration, IQAC and Innovation Com Incubation Center, HRDC and College Development Council. He has already served as Registrar at Berhampur University. He has total 111 publications in Scopus and ACI Index journals, books and proceedings. He has 41 international, 14 national, 11 article in books, 32 conference proceedings. He has edited 2 books and 11 technical reports. He has cumulative citation index, Scopus and ACI of 716 with H index 16 and I-10 index 22. He has successfully completed 10 major research projects, including 2 international projects, 2 major projects, and 1 consultancy project are also going on. Positions of chair, member of SEAC and OSCZMA, Government of Odisha, 2-term seats. International academic exposure, besides Commonwealth Fellow, United Kingdom. He worked as visiting scientist at Walker Institute, University of Reading, UK, Ocean Research Institute, University of Tokyo, and had many academic visits to different universities or institutions in United Kingdom, Australia, Japan, China, New Zealand, Thailand, etc. He has guided 13 PhD and 8 MPhil students. With this brief introduction, I welcome to Professor Pratap Kumar Mohanty sir to deliver his valuable talk.
Thank you, sir, for your very nice introduction. I also profusely thank the principal of Roland Institute of Pharmaceutical Sciences and all the faculty members for their very warm welcome and a kind invitation to deliver a lecture in this important training program sponsored by AICT. So, am I audible to all of you? Hello?
Yes, sir, audible, sir.
Yeah, okay.
Audible.
So, may I know just my audience, who are my audience? They are from, they are all faculty of pharmaceutical sciences?
Yes, sir. Yes.
Okay. So, I think all of, how do I go? I will first make a presentation and then there will be discussion at the end.
Yes, sir. You can continue with your presentation. At the end, all questions will be asked.
Okay. So as you see here, I will be talking on climate change, and I'll be focusing on the impacts on human health. So this should be the outline of my lecture. I believe the slide, movement is okay. Are you able to see the second slide? Hello.
Yes, sir. We can see the movement of slides.
Okay. So this is the outline of my lecture. I will be talking a little bit because this is a audience whom I should introduce what is climate change or global warming hypothesis, and then I will be talking a little bit on history and anatomy of climate change. What is the history of climate change and how it has evolved and from where it has evolved. So that is anatomy of climate change. And then how much climate change, everybody now talks about climate change. Anything that happens, okay, this is because of, nobody of course is saying this COVID is also because of climate change. So, but anything that happens, now people attribute climate change as the reason. So how much of this climate change is natural and how much is anthropogenic, whether we can quantify it, that also I'll just give a little bit of focus on that. Then I'll show what are the significant changes observed till now, both at the global as well as regional level, particularly focusing on India and Odisha. And then the future climate change, what the climate will be in the future, both at the global and regional level. And then how both this present climate change as well as the future climate change, what kind of impacts it has. Already it has some impacts, and it will have further more impacts if we believe the prediction of the climate change. And but I will be discussing mostly on heat wave and human health, and then other climate extremes and human health. How because of the future climate change, how the health human health will be affected. Okay. So we are all concerned about climate change, and because this is a very controversial science. Why I say, although I belong to climate science, so this is a very controversial science because some people say that climate is changing. Some people say that no, climate is not changing. It's a normal cycle. So we will go through this. So this is controversial science of the 21st century, and it because climate change has affected everything that we do in our house, outside, and that is how it has become very challenging also. So it is not so that is how it is not just a scientific concern. It has become a concern of every human being, common man, and encompasses all kinds of activities starting from economics, sociology, geopolitics, and health, agriculture, water resources, and whatnot. So the potentially devastating effects of climate change on human society are drastic changes in, because that this part I will be discussing mostly on health, but it has also drastic effect on agriculture, economy, water resources, coastal regions, and the extreme weather systems like storms and natural disasters and biodiversity. And what is the most lurking threat is, if you believe that the climate is changing and the oceans are warming, the atmosphere is warming up, then there is a huge reserve of methane which could be released because of the ocean warming, and that would further accelerate the warming that is happening today. So just I want to introduce the topic of climate system, because if we have to understand the climate change, we have to understand the climate system. But see, this is a very short time, but still you can just see how complex the system is. There are interactions in the four spheres, from the ocean, atmosphere, and the space. So the energy that comes from mostly is the sun, is the energy source of energy, and then how this energy is distributed in the atmosphere and ocean, and what are the different components which are playing roles in generating the climate system or the changes in the climate system. So that is actually one of the most complex processes that is taking place, and fortunately, it is a common effect not only of the climate scientists, but there are basic scientists, there are computer scientists, there are social scientists, and even there are people from medical background. So all of them have come together to devise these climate models, which can integrating all the components of the climate system, and that is how the climate is forecasted. Because prediction of a very complex system is difficult, and it also equally difficult when it, because of its spatial and temporal scales, because climate is a very large scale phenomena. Over a minimum period of 30 years we take a climate scale. Similarly, the space scale, it can be entire globe, or it can be a country, it can be continents. So that is how it becomes very challenging for predicting the climate system. And now you might have heard that over the years, climate change is a recent terminology which is used, but earlier people used to say it is global warming. So, what is this global warming and how it is different from climate change? So that just to introduce you, uh, the question is, can the future really be as bleak as scientists are predicting? Now, all of you know that climate has changed, or climate is changing, and the change that is going to happen is also very, very bad, which will have a lot of implications on our socio-economic, agriculture, as I told you, health, and other aspects. So this whole debate of global warming theory and its possible impacts, more than any other controversy in science, demonstrate the humanity of scientists and the politics of new scientific ideas. And the climate science, actually, I will tell you how over the years there are different terminologies used, like global warming or climate change, and then I'll come to that. So I'll also give examples of the link of climate science to society, because although it is called as a science, it is very much impacted by the social processes, society. So that is what I have written here. Day after tomorrow is a, uh, many of you probably know, it is a film where paleoclimatologists suggest that considering the present rate of climate change, this leaning tower of Pisa will be submerged and the entire globe will be submerged. So, so it creates a lot of curiosity. The climate science thus involves curiosity tainted with ambition, ego, and the fame. And the history of global warming hypothesis clearly shows that science is deeply influenced by the society and vice versa. I will give one of the examples of that, how the climate science is influenced by the society, or how the society has influenced the climate science. So this is one example here. Uh, why I say the climate science is influenced by the society, or how the climate science developed. Actually, it is in 1896, one scientist called Arrhenius, Swedish scientist called Arrhenius, he was the first person to say that because of our activity, we are responsible for adding carbon dioxide to the atmosphere, and as a result of which there is warming, in the atmosphere. And but nobody at that particular of time believed, Arrhenius, not even his scientific colleagues, forget about the common man. But then, so the reason for the late acceptance of the climate change. So we did not think at that point of time. I will tell you when the climate change was, believed that okay, climate is changing, and then there was effort at the international level, at the national level, and so on and so forth. But had we accepted the hypothesis or the theories put forth by Arrhenius at that point of time, probably we could have saved our climate to a greater extent. So this picture gives, the media coverage of climate change. And if you can see, it is 1890, 1888 onwards. Media coverage before that is very, very low. This media, I have quoted three newspapers: Guardian, Independent, and Times. All are foreign newspapers, particularly US. And see, it started just in 87 and then peaked in 1988, and then very sharp peaking happened in 89. So as you can see, in 1988, because of the media coverage, IPCC was formed. International Panel for Climate Change was formed, and then this IPCC 90 meeting were held in 1990. You see the maximum coverage in the newspaper. So this is how the climate change science has been accepted, and media played a very important role there. And if you look at this below graph, actually there are three curves. One is called climate change curve, another is called global warming, the dotted line is greenhouse effect. So these three terminologies are used at different times. As you see, it is earlier, most of the peoples were using greenhouse effect, and then subsequently climate change and global warming were used. But after 89 or after 90, after the formation of the IPCC, nobody talked about greenhouse effect. Everybody is now talking about climate change is at the top, and below that is global warming. So this is how these three terminologies have evolved, and this picture is nothing but your day after tomorrow. So the media, actually, what you all of you know what the media wants. Media wants some masala, and they got the masala from the climate change science, that if this is how the prediction is done, if this is how the climate is changing, probably the entire globe will be submerged, and the leaning tower of Pisa, the tallest tower, will be submerged. So that is how the climate science was accepted by the scientific community, by the leaders of different countries, and then there was effort at national and international level. So this slide actually why there was a significant delay in accepting the global warming or climate change hypothesis. So that I told you 1896 Arrhenius told about the climate change, and it was subsequently confirmed by Thomas Chamberlain. But this conclusion was that the carbon dioxide release will create warming in the atmosphere as well as in the ocean, and which will finally change the climate system, was not accepted then. And it is during 1950s, there is one scientist called Roger Revelle, who was the director of Scripps Institution of Oceanography in California, US, revealed that the complexities of the surface ocean chemistry are such that it returns much of the carbon dioxide that it was absorbing, and showed that because of the peculiarities of ocean chemistry, because from 1896 to 1950 it was a long period, and by that time already the ocean chemistry had changed, and oceans, instead of absorbing the carbon dioxide, some of the ocean, actually the southern ocean mostly absorbed the carbon dioxide, but some, because ocean got saturated and then ocean started releasing the carbon dioxide to the atmosphere. So oceans would not be in a position to accept the carbon dioxide, and that would be disastrous. And in early 1960s, this Charles Killing, so Killing curve therefore was designed later. Killing curve is nothing but the curve which shows the carbon dioxide concentration with time. Yeah. So this is what is called as the anatomy of climate change. If you can see this, there is lots of ups and downs in our climate system, and this, if you believe this is about 100 million years. This is 100 million years. This is zero is the present, and then we go back to around 800 million years, and then go forward 100 million years. So if you look back, so these are different ages: greenhouse ages, ice ages, greenhouse ages, ice ages. So there is a cycle going on. Wherever there is an ice age, you have cold system, and wherever there is a greenhouse age, you have warming. And if you look at the present, so now we are here, just from, we are going down toward, from the peak towards an ice age, So this is from the paleoclimate records, and so there is nothing to be panic. If you believe this paleoclimatology, there is nothing to be panic, because we have already had more kind of warming in the past also as compared to the present warming rate. If you look at this peak and the peak here, so there was the warming was much more in the past also, around between 600 to 400 million years back. So there is nothing to be panicked. Probably we may consider it as a cycle. But the only difference in the past climate and present climate is, here in the present climate, the climate system or the climate change is not only because of the natural processes, there is a lot of contribution from the anthropogenic system. That is what is most worrying and difficult challenge for the scientific community. So you can see causes of climate change. There are natural causes of climate change: shifts in the Earth's orbit and tilt, position of its axis, solar activity, volcanic eruptions, and atmospheric aerosols. But these was the things in the past, as I showed you in the paleoclimate. But what is very disturbing is the human-induced changes into the climate system, which is very recent, after 1860, after the start of the industrial era, which is the time is 1860. So this is artificially generated greenhouse gases. Aerosols are released to the atmosphere, and change in land use and land cover, urbanization, deforestation, our lifestyle, and so on and so forth. So now, if you look into the natural causes of climate change, so volcanic eruptions, many of you know that there were several volcanoes which, because of which the sunlight could not penetrate to the surface of the earth for even years together. One of them is Sunda in Indonesia. There are so many. And then variations in sun's output. So there are variations in the sun's output, which is also responsible for the climate change. And then most of you probably know about this Milankovitch cycle. So he talks about the three cycles mostly, that is called precession, obliquity, and eccentricity of the Earth. Uh, and each of them has a cycle and cycle is different for different. Precession has a cycle of about I'll tell you, this obliquity, tilt of the axis, is about 41,000 years, and eccentricity about 100,000 years, and precession is actually is 26,000 years. So how these kind of processes are also responsible for climate change, and you can see here, if you link in these stages of glaciation, hot and cold phases are linked to the different phases of eccentricity, different phases of obliquity, and different phases of precession. So just to, because many of you may not be knowing what is these processes, precession, obliquity, and eccentricity, I have a slide to explain you. Changes in eccentricity, which has a cycle of about 100,000 years. So if you look at these two figures, see here the eccentricity is less because the Earth has a elliptical path. Earth is covering the sun in a path that is called an ellipse. But here the eccentricity is less. You see this blue mark here, but now the eccentricity has increased because this goes on with time. So when the eccentricity is more, and the Earth is closest to the sun at some point of time, Earth is farthest from it at one point of time, and that is, we call it as perihelion and aphelion. Probably all of you know this. Perihelion is the point where the Earth is very close to the sun. Aphelion is the point where it is farthest from the sun. Perihelion mostly in January, and aphelion during July. So this is how, because of the eccentricity, change in eccentricity, there can be change in the insolation. When the Earth is closest to the sun, it will have more. We will receive more radiation at the surface of the Earth. When it is farthest from the sun, the radiation is less, so it will have impact on the Earth's climate system. So similarly, obliquity, the tilt of the Earth's axis, you can see the Earth this is the perpendicular of this one, and this is the axis actually, this one you can see. So the tilt is between 22.1 to 24.5 degree. That is the maximum variation in the tilt. And at present, Earth's axis is currently tilted at 23.4 degrees. Maximum is 24.5. It was maximum, and then now it is going down, and it is at present 23.4 degrees, or about halfway between its extremes. And this angle is very slowly decreasing in a cycle that is, the cycle is 41,000 years. So it was at its maximum tilt 10,700 years ago. And whenever you have a maximum tilt that is 24.5 degree, you will have more extremes. So that is the point of discussion for impact of obliquity or the tilt of the axis with the climate system. Similarly, precession. What is precession? when the Earth is, rotating around the sun or around its own axis, actually precession is an oblique motion of the axis of the Earth. When Earth is rotating around its own axis, the rotation has a oblique motion, and that we call as precession, and it has a cycle of about 26,000 years. So you can see here. Here the cycle is not completed. This line is not completed, and therefore you can see here this dotted line and this line are very close to each other. But here the cycle is completed. That means the oblique motion has been completed, and you can see the gap here. So this is how this can have impact on the climate system, like the rotation of the Earth's axis, and along with the rotation there is also precession. But let me tell you, these processes, as you see from the cycle, one is 100,000, another is 41,000 years, another is 26,000 years. So this very long-term changes, and the changes are takes place in a very slow manner, and therefore climate system is not much affected because of those things. And this is verified here. Sun and global warming, a misconception. People believe that probably there is much of radiation coming from the sun in the coming days or in the recent times, and that which changes the temperature of the atmosphere. So if you look at this curve, this below one gives you the solar cycle, which has a 11-year cycle. See, if you see from the peak to the trough, from the crest to the trough, this cycle is 11 years. So that every 11 years there is some energy more, and then it reduces after 11 years. But if you look at the temperature here, temperature curve, which is actually observed, this is observed temperature, global surface temperature. This is not following the solar cycle. So this clearly suggests, and this is what is plotted here, the temperature variation with respect to time. So this clearly suggests that the solar energy, which is coming and which has a cycle, because of you may consider the precession, you may consider the tilt of the axis, or you may consider the eccentricity. They are not, one in one with the way the surface temperature is changing, and therefore the impact of these on the present climate change is not much. That is what you can conclude. And there is another important revelation, that the climate swings. What is that climate system swings? It is swings from, as you have seen in the paleoclimate, medieval warm period, then ice age, and then the present and future climate. So this is how the climate swings. See, this is the Earth, and this is the equator, and we have ITCG. We call that as intertropical convergence zone. Actually, it is normal position is between 5 degrees north to 5 degrees south, but it is not always in the normal position. Whenever the ITCG here, this red line actually is the ITCG. Whenever the ITCG is towards northern hemisphere, you have a warm phase, and whenever the ITCG takes a southward movement, then you have an ice age or a cold phase. So this kind of things goes on. 2000, you can see ITCG here. Then 2100, it is predicted that ITCG is going further north. That means we will have a more warming because of the position of the ITCG. And this is what is related from medieval warm period to the ice age and to the present state. And beyond these connections of climate change, there is also something happening in the oceans. So this is the role of ocean. Beyond the carbon dioxide connection, what is happening in the ocean is there is also different types of currents which flow in the oceans, and which are also responsible for the climate change. And this is what I am showing is the Atlantic Ocean, and this red line is a very strong current which we call as the Gulf Stream. And Gulf Stream influenced the entire North American climate system. And now it is observed that the Gulf Stream is gradually weakening. Gulf Stream is gradually weakening, and therefore the impact it had on the North American climate system will also change. And so this is actually the temperature, troposphere and stratospheric temperature. And this is the temperature profile of the atmosphere. Actually, in the troposphere, the temperature decreases with height, then it remains constant. Stratosphere, it decreases. Stratosphere, it increases. Mesosphere, it decreases, and you have the lowest temperature at the topmost layer of the mesosphere, and then gradually it increases and goes toward the sun. This is how the temperature varies. But now what is observed is, see, if you see, this is showing an increasing trend of temperature in the troposphere, that we are all seeing that the temperature of the Earth's atmosphere is increasing. But you see, stratosphere, there is an increasing of temperature. But you see, stratosphere shows a decreasing trend of temperature. What could be the impact of this? You have troposphere, which is the temperature is increasing. That means the air is warmer here. Warmer means lighter, unstable. And stratosphere, you have above the troposphere, the temperature is decreasing. So decreasing means colder, and it will be heavier, and therefore because it will be heavier than the troposphere, if the temperature decreases, that air from the stratosphere will come to the troposphere. So there will be more stratosphere troposphere interaction in the future if this is the way the temperature changes. So that is more devastating. Now the entire climate system is limited to troposphere. But if this is the way the temperature changes, then probably the climate system will extend from troposphere to the stratosphere. So that is the greatest danger that we can foresee. And now what is seen is the temperature that is the change that is happening is not uniform all over the globe. It is somewhere there is a cooling and somewhere there is a warming. So the highly non-uniform, like this. So this I just wanted to, initially I told you, now the climate system which is changing contributed because of both the natural processes and also the anthropogenic process, our activities. But the biggest challenge before the scientific community is to know or to quantify how much is contributed because of the natural processes and how much is contributed because of the anthropogenic processes. So just to explain that, actually, if you look at this black one is called as the observation. Actually, how the observation is going on, global temperature change. And then if you include the natural and human factors, this spread. And then if you include only the natural factors, see, this one is natural factors, and this black one is observation. That means if we only say that the climate change is only because of natural processes, it is not, although it was agreeing initially up to here, 1940 or 19, maybe up to here, but at a later stage, they are going apart. So they are not obeying with each other. But if you include human factors as well as natural factors, see, there is a correlation, coincidence between the observed one and the what is changing. So that is how we believe that the change that is taking place, climate change that is taking place, is because of both natural processes and human induced changes or anthropogenic process. But quantifying that is really difficult. So this is again the same experiments done to understand the behavior of climate change both due to natural processes and man-made changes, and how these changes are again different, at different areas of the globe. Like North America, the changes are different. Asia, the changes are different. Europe, the changes are different. Like that, at different parts of the globe, somewhere the natural processes are more, somewhere the anthropogenic processes are more, and therefore the behaviors are entirely different. Okay, so this is actually the anthropogenic climate change. All of you know that carbon dioxide, the culprits are carbon dioxide, methane, nitrous oxide, chlorofluorocarbon, and these human-induced changes like our activities, industrialization, transportation, agriculture, and mostly the energy sector, which releases the carbon dioxide and other these greenhouse gases. So this is our activities. So this diagram is interesting. All of you can see climate change and development. See, all of you know that our human has been created from this, which is at the beginning. So you can see it's a great journey, as I showed you, 800,000 years. It took 800,000 years from monkey to the modern human being. But now we are in a reverse trend. We are in a reverse trend because of the climate change. So now you can see here. So probably the dress that we are wearing, because of the warming, we may not require any dress. So we may go back to the trend is a reverse. So the question is, should we allow this reverse trend to occur? No, certainly no. So if it is no, what we can do to change this, to stop this change, reverse trend? Let us see. So this part I will very quickly move. All of you know that the carbon dioxide is changing, gradually increasing, and who is contributing, how much, all these developed nations, America, Europe, they are contributing most. There are top 20 emitters of carbon dioxide, energy related carbon dioxide: America, China, Russia, Germany, like that. So this part I will not discuss much. And okay, this is greenhouse gas, human induced greenhouse gases. I told you, see, there is a sudden peak in the carbon dioxide, methane, and nitrous oxide only after the industrial development took place. So that is what is very clearly showing that until some years there was nothing, but there was a big jump, and this jump is mostly because of our industrialization, which is just 200 years back. And the sector-wise contribution, if you look at the maximum contribution is from the energy sector, followed by agriculture sector. Okay, this actually is a very important diagram. Just I wanted to explain you. This is also the Arrhenius explained it. The greenhouse effect, all of you know greenhouse effect. So what is happening is sun is radiating energy. Energy comes to the surface of the earth. Earth acts as a black body, and the earth also radiates energy. So this is a normal greenhouse effect. Sun is radiating energy, earth is receiving, and then earth is radiating the energy back. And because of some of the greenhouse gases are there always. You see, water vapor is a naturally occurring greenhouse gas, and some of the radiation which goes from the surface of the earth also comes back again to the surface because of the presence of greenhouse gases. So this is a natural process or natural greenhouse effect. But what is happening today is called as enhanced greenhouse effect, and because of which there is warming. So the sun is radiating. As I showed you, sun radiation is not increased or has not decreased. But what has changed is the concentration of greenhouse gases in the atmosphere, and as a result of which the amount of radiation which was going to the space is not going. See this, thicker curve, the maximum amount of radiation which goes back because of the Earth acts as a black body and radiates the energy back. But then, because of the presence of these greenhouse gases like carbon dioxide, nitrous oxide, they are coming back to the surface of the Earth, and therefore that is resulting in the heating of the atmosphere. So this is most concern, and therefore we have to check this release of these greenhouse gases somehow, and which is maximum, carbon dioxide emission is coming from the energy sector, so we have to change at the energy sector. And your methane mostly coming from the agriculture sector, so we have to change from the agriculture level. Okay, so observed changes in global or regional climate. Whether I have time or not, I don't know. Okay, so these are some of the observed changes which have already taken place, like how the temperature has risen, and then you can see here the point at 1940 up to here, or you can say up to 1980, it was all negative anomaly of temperature. Only the positive anomaly started after 1980. So, and it is gradually increasing. So we are more concerned about from 1980 onwards. And this is the recent picture, gives up to 2020, and you can see there is a change of surface temperature, air temperature, mean surface temperature of the globe. The global average temperature has already increased by 1 degree centigrade since pre-industrial times. So this is what is the period of pre-industrial time. Our industrialization started from 1860 onwards. So from pre-industrial time to the present, the temperature has already increased by 1 degree. Significant changes observed in the ocean. Ocean also is simultaneously changing as in the atmosphere. As I told you, major carbon sinks are now called as carbon source. Carbon dioxides are now released from this ocean to the atmosphere. Huge reserves of methane could also be released. Sea surface temperature, because of the warming of the sea surface temperature, and sea surface temperature has also increased by 1 degree centigrade average during 1951 to 2015, and markedly higher than the global average of SST warming of 0.7 degree centigrade over the same period. Ocean heat content is also increasing, and with this increase of sea surface temperature, your glacier melting, there is a rise in the sea level, and the sea level rise has taken place globally, and you can see, but the sea level rise is much more in the North Indian Ocean, which has occurred at the rate of 1.06 to 1.75 millimeter per year during 1874 to 2004, and it is likely to be accelerated to 3.3 millimeter per year during 1993 to 2007, which is comparable to the current rate of global mean sea level rise. So we will have a higher rate of sea level rise in the North Indian Ocean, which includes your Bay of Bengal and Arabian Sea. So in addition to sea level change, so what is happening is, because there is a carbon dioxide concentration, the pH of the seawater is changing. Ocean acidification has started, and when the pH of the ocean water is decreasing, and there is a decrease of 0.1 since the beginning of the industrial era. So this is again another threat. So some of the changes that we see here is how the annual average, this is for the India, how you can see there is the annual average temperature is increasing in India. The precipitation over India, you see there is, it's not increasing, but more or less it remains same. or you can see that is sometimes there will be decrease. Then sea surface temperature, as I showed you, it is increasing with time. Annual average of this is sea level is increasing, and then this is snow cover, Himalayan snow cover. See, snow cover is decreasing. Snow cover is decreasing with time. You can see here, this one very clearly shows there is a decrease of snow cover with time. So these are observed changes. And then the predicted changes. And for prediction, we need climate models. And these are some of the data or models used. One is called CORDEX, Coordinated Regional Climate Downscaling, Coupled Model Intercomparison Projects, and NASA Earth Exchange Global. And then there are predictions for 2040 to 2069, from 2070 to 2099. One is called near future, another is far future. I will show you some of the changes that is going to happen in India and globe. So this is observed changes in India, that is land mean annual and seasonal surface air temperature. You can see how it is changing. This is annual change. This is change during winter is very less. Pre-monsoon change is maximum. Monsoon change is again less. Post-monsoon change is less. This is the mean temperature, how the mean temperature is changing or has changed over the period 1986 to 2015. And it has been estimated that India's average temperature has risen by around 0.7 degrees centigrade between 1901 to 2018. But the change is more taking place during pre-monsoon, March to May. Why? The question is why pre-monsoon changes are more both in the maximum as well as the minimum and in the mean. I will just give an answer to this. See here, this shows the changes in the humidity. One is called specific humidity, another is relative humidity. And that means the atmospheric water vapor content of the atmosphere is also increasing with time. And this increase, if you look at the specific humidity in the pre-monsoon, is also higher. Relative humidity is also higher. So what it suggests is, whenever you have more water vapor in the atmosphere becomes lighter. Do you agree with me? Are you hearing me? If you introduce water vapor into the atmosphere becomes lighter and unstable, and therefore if you have only dry air, atmosphere is stable just from the molecular weight of water vapor and dry air. You can calculate, and that because of that, you see, monsoon or pre-monsoon we have more water vapor, and therefore you have more weather disturbances. But during winter it is dry, atmosphere is stable, so you have less disturbances. So that is the reason. And this is cold nights. This is very interesting. You can see here, cold nights, there is a sharp drop in the number of days, cold change in days. Then earlier, what was the number of cold night days? It has reduced, or it is reducing significantly. Cold days are also, there is a declining trend, whereas warm nights are increasing. It is showing an increasing trend, and warm days are also showing an increasing trend. These are all observed changes. Similarly, observed changes in Indian land mean annual and seasonal frequency indices of daily extreme temperature, cold nights, cold days, warm nights, and warm days. So this also seasonal changes, how the things are changing. Okay, this is temperature extreme. Cold nights, the temperature has increased. So just here, why there is a cold nights are decreasing, whereas warm nights are increasing. Or cold nights, there is an increasing temperature anomaly, whereas warm and increase is more as compared to the warm night. See, here it is 0.12 and here it is 0.13. why this is happening. We'll discuss that. Okay. So what it has been observed is over the 30 years period from 1986 to 2015, temperature of the warmest day and the coldest night of the year have risen by about 0.63 degrees centigrade and 0.4 degrees centigrade respectively. This is a very interesting diagram uh, which gives you the picture of little ice age, then the medieval warm period, and also the Roman warm period. See, LIA is the little ice age, medieval warm period, and Roman warm period. So this is the period 1550 to 2200 years, 650 to 10,050 years, 100 to 50. So there are actually, this is a record of speleotherms. Speleotherms are nothing but you will find in all caves there will be this precipitation will go into the caves, seep inside the caves, and also the carbon dioxide enters into it, and then in the course of the time there is a formation called as speleotherms, which are considered as climate proxies, and from that you can determine the oxygen isotopes. These are nothing but oxygen isotopes for record from the speleotherms from different caves, and one of the caves here is Gupteshwara cave in Odisha, in the Koraput region. So this shows how you see wherever there is a decline, this shows the dry period, and wherever there is a peak, this shows the flood period or wet period. So over the years, in a paleoclimate system, you can also study how the things have changed. There was warm period and cold period, or wet period and dry period. So this is how the precipitation has changed between 1976 to 2005, and the summer monsoon precipitation, particularly monsoon precipitation, has declined by around 6% between 1951 to 2015, and with a notable decrease in the Indo-Gangetic plains and Western Ghats. Western Ghats, which was supposed to get maximum rainfall, is not getting. And over central India, the frequency of daily precipitation extremage with rainfall intensities exceeding 150 millimeter per day increased by about 75%. So there is an increase in rainfall in the central India, and there is a decrease in the rainfall in the western India, Western Ghats region. So this is how the anomaly in the spatial anomaly. And droughts also, overall decrease in seasonal summer monsoon. I think I am consuming my time. Excuse me. Hello.
Yes.
Dr. Patra.
Yes, sir.
I have made to come to my. How much time I can take maximum?
Sir, you can take another 10 minutes to 15 minutes.
Okay, I will cover that. Health part. Okay.
Okay, sir.
So droughts, actually, this is how the droughts have occurred over the periods of time. Overall decrease of seasonal summer monsoon, as I showed you before, during the last 6-7 decades has led to an increased propensity of droughts over India, and both the frequency and spatial extent has increased between 1951 to 2016. And areas which are affected by drought are southwest coast, as the rainfall over the Western Ghats has decreased, southern peninsular region, and northeastern India. Odisha is also included there. So approximately 2 droughts per decade have been observed in these areas. And that is the area affected by droughts has also increased by 1.3% per decade over this particular period, 1951 to 2016. This is how the carbon dioxide in India has changed. These two stations. One is called Sinhagad in India, and then this red one is Mauna Loa in the Pacific. Both are equatorial stations with same latitude and longitude, almost equal latitudes between 18.3 to 19.4 degree. But you see the changes in the carbon dioxide, how the cycle is changed. In the Indian region, it is extremely high as compared to over Pacific. So the region was investigated. So higher seasonal cycle amplitude at Sinnabad, which is an Indian station in the Western Ghat region, compared to the observations at Mauna Loa, the red one, in the Pacific region, is caused by strong local regional biospheric activity as well as changes in nearby oceanic fluxes. What is biospheric activity? See, that was also investigated. The carbon fluxes in the Indian forests vary widely across the ecosystem. There are several ecosystems, forest systems, Kaziranga forest in the northeast India, Haldwani and Barkot in the north India. Then you have forest Bitul and central India, mangroves of Sundarban and our Odisha mangroves, Kosi, Katmal forest in the North India. So they sequester carbon at different times. See, here if you look at the Sundarban or the Odisha mangroves in Sundarban, East India and Kosi, North India sequester maximum carbon during post-monsoon, whereas mangroves in Pichavaram in the South India, they sequester maximum carbon during winter season. Similarly, so there is a seasonal variation. That is what is very clearly seen here in the carbon dioxide curve, as compared to very less seasonal variability over the Pacific. And this diagram shows that actually the net amount of carbon exchange, NE, and which is negative means actually there is a offtake. The system, the forest systems is taking the carbon dioxide, using the carbon dioxide, and positive means it is leaving the carbon dioxide. So there is a huge spatial variability in the India itself. So that amounts to the previous curve, this curve that you see in the carbon dioxide curve. Similarly, we have also variability in the, this is carbon dioxide variability, this is methane variability in the Indian region, Seychelles, then this is Sinabad, and this is your Mauna Loa. So from this, we have seen that how the climate has changed. So if I ask, is the climate change happening? The question is yes. And how it will happen, or what kind of future changes are occurring, that is shown here. Like it is shown for two periods. One is from 2040 to 2069. Another is for 2070 to 2099, based on climate model predictions. And it has been predicted. You can see here the temperature and precipitation, how it is going to change in the near future and in the far future. And it has been predicted that approximately there will be a rise of 4.7 degrees centigrade and 5.5 degrees centigrade by the end of the century, by 2099, compared to the base period of 1976-2005. And the frequencies of occurrence of warm days and warm nights are also projected to increase by 55% and 70% respectively. Warm days will increase by 55%, whereas warm nights will increase by 70%. So this is what is the projected change, future change in the climate system. Similarly, so these are temperature, precipitation, and sea level changes that is predicted up to 2000, that is 2100. Okay, these are some of the predicted changes in the monsoon. Okay, projected changes over the Indian region. So by the end of the 21st century, average temperature over India is projected to rise by about 4.4 degrees centigrade relative to the recent change. That is, you have seen only 0.7 degrees has changed. but it is expected that there can be a rise of about 4.4 degrees centigrade by the end of 2100. So these are some of the impacts that you have already experienced because of the climate change. There is increase in the natural disasters. Frequency of natural disasters has increased. Some have decreased also. Windstorms has increased. Floods are increasing. Droughts are increasing. Heat waves are increasing. I will just discuss a little bit on heat wave and health. So this is the changes in the cyclonic storms, depressions, cyclonic storms, and severe cyclonic storms in the pre-monsoon and post-monsoon season, particularly in the Bay of Bengal region. And if you look at this, see there is no change in the depression, but there is an increase in the cyclonic storm and severe cyclonic storms, and particularly during this period. This is called as the warming period, and this is called as the cold period. Similarly, there is, you can see here, the frequency is not changing. Frequency is decreasing with time. Here you can see there is a decrease in the frequency of the cyclonic storm, but the intensity is increasing. Intensity of cyclonic storm and severe cyclonic storms are increasing, but this curve shows that the frequency is decreasing in the Bay of Bengal. See, this is along the Odisha coast. Again, the frequency is also decreasing, but the intensity is increasing along the 7 districts of Odisha. Okay. This is climate change induced migration in Vietnam because of the flooding associated with sea level rise or the flash floods. People are suffering more flooding, and this is in climate change induced migration from Bangladesh to India. So this will have serious, socio-economic and health impacts in the near future, because I will show you this diagram. Please go through. This is a very good paper by Newman et al., which predicts the population change in the low elevation coastal zone in the year 2030 and 2060 with respect to the base period of 2000. You see there is a big rise. These are for the this is baseline 2000. 2030 there will be a rise. 2060 there is a rise, and here for Asian region, Southeastern Asia, there is a big rise here in the population. So this gives the population. You can see how much it is rising in millions. In India, you can see India, it is now 63.9 in the LECZ, which is 6.1 of the total population, and we are expecting 120, almost double in 2030, and 216.4 in 2060. Similarly, Bangladesh, this is the change. Vietnam, this is the change. Indonesia. So if such kind of population change is happening in the low elevation coastal zone, they are more vulnerable. So that is how this kind of things is going to happen. There will be a lot of climate change induced migration, because if you look at Bangladesh, in the low elevation zone, almost how much? 48.7% of the population live in the low elevation zone of Bangladesh, as compared to 6.1% in India. So if there is slight increase in the sea level rise, or there is flood or cyclone associated storm surge, they will be totally submerged, and there will be migrations of this nature. This is heat wave. See, there is very huge temperature over Odisha over the period, and this has led to discuss about the impact of temperature and malaria. See, this curve, this diagram shows what is the optimum temperature required for malaria parasite, both your falciparum and vivax. This is the optimum temperature required, 25 to 27. And if you look at the temperature distribution in Odisha, in most of the time, you have the optimum temperature available, and therefore the malaria and dengue fever are projected to increase in Odisha as well as in different parts of the country and the globe. This is how what this shows the areas which are prone, areas at risk because of malaria transmission and potential risk under different scenarios of climate change. So this is again the heat wave study for different regions of Odisha. We have divided the Odisha into 4 zones, and you can see here, this is coastal Odisha, north central Odisha, western Odisha, and southern Odisha. And this is a parameter we call it as heat index. So there are extreme danger condition, extreme extreme caution, danger. So different conditions are there, and it starts from 1st March to 30th June. So which are the period where which are experiencing extreme danger conditions, and when the extreme danger conditions are experienced, you can also study using the heat wave indices. That is done for different regions of Odisha also here. This is a heat index for 1998 to 2008. So from this you will know what are the regions which are experiencing different types of conditions, and accordingly you can take precaution. Fortunately, southern Odisha, there is no extreme condition. So coastal Odisha is also experiencing extreme danger and extreme danger conditions starting from mid-April or even end of March. So climate change over the next decade, this is happening. Okay, this is the change in the frequency of cyclonic storms. I told you the frequency is decreasing, but the intensity is increasing. That is, this diagram shows that because of the climate change. And what is disturbing is you see the rainfall pattern or the flow in the rivers. If you look at the rivers Mahanadi, there is increase in the precipitation in this region, so we will have more flooding in the future. Similarly, Brahmani, Ganga, there will be more flooding. But in the North Indian rivers, there is severe shortage of, particularly in the Sabarmati, Luni, Mahi, Pennar, there is shortage of water, and there will be drought conditions there. Okay, this is how the different states which going to experience the temperature change because of the climate change scenario. So this is, I will just discuss some slides of human health. So climate change and health, the key facts are climate change affects the social and environmental determinants of health, like clean air, safe drinking water, sufficient food, and secure shelter. And between 2030 to 2050, climate change is expected to cause approximately 250,000 additional deaths per year from malnutrition, malaria, diarrhea, and heat stress. As you have seen, because of the predictions, the heat wave days are more, the drought condition is becoming more, food security is gradually is decreasing, malaria and dengue fevers are increasing. So there will be, it is estimated that almost 250,000 additional deaths per year because of this, kind of health related diseases. And the direct damage caused to health, excluding cost in a health determining sector such as agriculture and water and sanitation, is estimated as at 2 to 4 billion US dollar by the year 2030. And areas with weak health infrastructure, mostly the developing nations like I just showed you, Bangladesh, Vietnam, Indonesia, they will bear the brunt. They will be the maximum vulnerable. And reducing emissions of greenhouse gases through better transport, food, and energy use choice can result in improved health, particularly through reduced air pollution. And higher temperature, extreme weather events, and higher climate variability have been associated with an elevated risk of heat strokes. Warmer, higher moisture conditions, as I showed you, moisture conditions are increasing on average, are also more favorable for the spread of vector-borne diseases such as malaria and dengue fever. Food security is decreasing. progressively, and there will be greater pressure due to rising temperature, heat extremes, floods and droughts, which may lead to famine and death of the vulnerable people. And coastline, along the coast, a lot of people living in the low level coastal zone will be submerged, and there will be migration risks, and there can be also health risks. Extreme heat and human health. Extreme high temperature contribute directly to the deaths from cardiovascular and respiratory diseases, particularly among elderly people. And the heat wave, there is example of 2003 heat wave in Europe. Even 1998 heat wave in Odisha, we had a death of about 2,000 death, and 2005 and 2012 also we had a lot of death because of heat wave, and which is going to rise. And then the air pollution related pollen and other aero allergen levels are also higher in extreme heat, and these can trigger asthma, which affect around 300 million people. And so there is a program now going on in India in collaboration with Germany, and that is called air quality assessment and the prevention of bad aerosols. How we can change the bad aerosols, how to improve the air quality. It's a big program going on in the at international level collaboration between India and Germany. Natural disaster and variable rainfall patterns and health impacts. As I told you, rising sea levels or floods or droughts can have famine, and then flooding and all many other communicable diseases. Mental disorders can also occur, just like COVID. There will be a lot of mental disorders, mental depressions. Many children are becoming orphan. So increasing variables rainfall patterns are likely to affect supply of fresh water is a big crisis in the near future. So there will be salinity intrusion in most of the coastal places. Fresh water availability will be less. So that will also lead to health issues, health problems. And then okay, malnutrition and undernutrition is also a big issue because of the food security and continuous drought and flood, and this will increase the prevalence of malnutrition and undernutrition, which is currently causing almost 3.1 million deaths every year. So climate change and the pattern of infection. Climate conditions strongly affect waterborne diseases, and changes in climate are likely to lengthen the transmission season of important vector-borne diseases and to alter their geographic range. As I showed you how the malaria and dengue fevers will spread over the entire globe at different regions. And malaria is strongly influenced by climate, as I showed you the optimum temperature for their growth. And the mosquito vector of dengue is also highly sensitive to climate conditions, and studies suggest that climate change is likely to continue to increase exposure to dengue. So measuring health effects, WHO has taken a lot of done major efforts in assessment of climate change and health. So what is it is doing is assuming continued economic growth and health progress, concluded that climate change is expected to cause approximately 250,000 additional deaths per year between 2030 and 2050, and 38,000 due to heat exposure in elderly people, 48,000 due to diarrhea, 60,000 due to malaria, and 95,000 due to childhood undernutrition every year. And the risk, who is at risk? The vulnerable people, elderly people, the coastal people living in the coastal zone, children. So these are the people who are at higher risk. And this is a very interesting one, that is cascading effect of climate change. This is, for example, a region may experience an abnormally long or intense summer heat wave. If there is an intense summer wave, suppose Europe in 2003, followed by intense monsoon floods that alternate with lengthening dry spells, so that low-lying coastal zones, especially on India's east coast, may witness rising sea levels, damaging property and increasing groundwater salinity. A rise in cyclone intensities will likely result in increasing inundation from the accompanying storm surge that turn approximate agricultural lands and lakes saline and completely destroy the wildlife system along the coast. Such sequences of events. So, just if you start from heat wave, it can have a chain of events. That is what is described here, leading to a chain of events. All are associated with climate change. But there are some multiple benefits of some of the things which you can adopt to a strategic transition to renewable. As I showed you, the maximum sector, that is carbon dioxide release, is from the energy sector. So there is need of intervention in the energy sector to change to renewable energy would reduce both greenhouse gas emission as well as water consumption required to cool thermal power plants. So low impact development and green building infrastructure can reduce both urban heating and air pollution. A reduction in air pollution would greatly benefit human and environmental health, improve the efficiency of solar energy generation, and even potentially aid in increasing the quantum of monsoon rainfall over India. An increase in rainfall together with measure for water harvesting would aid the restoration of groundwater levels, and restoration of groundwater level would not only improve water security and resilience to droughts, but also will help check land subsidence and consequently reduce the impacts along the coast, that is sea level rise and storm surge. So this is one example. Similarly, there is another example. If you do afforestation, why we are now encouraged to go for afforestation? It has a myriad of benefits. Like if you plant a tree, aside from mitigating climate change through carbon sequestration, trees also enhance the resilience to flash floods and landslides by improving soil retention, improve resilience to droughts by increasing percolation of surface water into the soil, improve resilience of coastal infrastructure and habitation by reducing coastline erosion, and also help in checking the sea level rise, particularly mangroves, reduce vulnerability to extreme heat by reducing ambient temperature. If you have good canopy, it will reduce the vulnerability to extreme heat and reduce the ambient air temperature and support native wildlife and biodiversity. So it will enhance the biodiversity. So these are best examples, and it has, you take one step, it will have a chain of effects, myriad of benefits. So that is what is we have to now do. And policy implications have been also decided because of this change that is going to take place in the because of the climate change. So many policies and individual choices are there, but for the cleaner energy systems and promoting the safe use of public transportation and active movement such as cycling or walking as alternative to using private vehicles could reduce carbon emissions. And it has been estimated that almost 4.3 million deaths per year because of air pollution alone can be checked. And it is necessary to develop, therefore, useful to usable research. And you can see how you can adopt, particularly in pharmaceutical science, how you can change to make you useful to usable research and apply your pharmaceutical knowledge to develop to adapt to the climate change related diseases and translate research to on ground or effective decision tools for adapting to climate change. And this will help in equity and providing social justice of the to the people who are at the bottom or at the vulnerable region of the society. So these are some of the WHO work plan on climate change and health. That is, one is partnership to coordinate with partner agencies within the UN system and ensure that health is properly represented in climate change agenda. Then awareness raising is another important agenda of the WHO, World Health Organization, to provide and disseminate information on the threats that climate change presents to human health and opportunities to promote health while cutting carbon emissions. Then science and evidence, to coordinate reviews of the scientific evidence on the links between climate change and health and develop a global research agenda. So the one that I presented is a kind of science and evidence link. So support for implementation of the public health response to climate change, to assist countries in building capacity to reduce health vulnerability to climate change and to promote health while reducing carbon emissions. So these are the four major agenda of World Health Organization linking climate to health. Probably this we have to, I think I have come to an end. Thank you all. Thank you. I'm sorry I took so more
No,
time,
no problem, sir. Sir, thank you. No problem, sir. So thank you very
but
much for
still
your
I,
detailed
I would be
presentation.
I would be happy if there are some questions.
Yes, sir. Yes. So
Maybe
thank you
another
very
five
much, sir, for
minutes.
your detailed presentation on climate change and how it is affecting the human health. So as per your presentation, it shows that the near future and the far future, the situation is
Yeah,
quite alarming. Our body
yeah,
has to be able to adapt to those changes. So there are few
changes.
questions from the participants, sir. So it
Why
is in the
sure.
screen. You can just see. Yeah. If there is
So
green
I'll
effect and ice age or peak and
yeah
valley effect, will this effect will continue, or we will be in a particular peak either in ice age or green effect age?
yeah. Now as I showed you, we were at a peak, and if we believe in paleoclimate records, we are now going down, and we may face an ice age uh, after maybe 100 million years. That was the period. It will take another 100 million years.
So there is one more question. What is the impact on nuclear weapon testing under the ocean?
Nuclear weapon testing, that I do not know, because it has to be assessed whether it is increasing the ocean temperature or not. Nothing, no studies has been done yet. I don't know. I'm sorry.
One more question is this.
Should I close this so that I can see the screen,
Sir,
the question?
yes, yes, yes. Your screen you can. So this is another question from Mr. Rohit Agarwal.
How the
How the
pollution or
pollution?
rise in uh, or rise in temperature and carbon dioxide content increase will have impact on animals. Okay. Yeah, it will have, see, it will have impact on animals, as I told you, both human as well as other animals. See, I was listening to one of the lectures. It was beautiful lecture. See, nature is behaving in such a way. Nature has behaved in the past. It has discarded many of the species in the past. So now that one lady was giving a lecture, that so probably now it is going to discard the human species. So the way the pollution is, particularly the amount of greenhouse gases is rising in the atmosphere, or aerosols are rising in the atmosphere, you will have more, cardiovascular problems. It is not only for the human being; it can also be applicable to different animals, and then carbon dioxide content increase will have impact on animals. Yeah, carbon dioxide content increase, particularly if you look at the oceans. I showed you, there is a decrease in the, I mean, pH. That means normally the ocean water is what, basic. That means the pH is more than 7, but it becomes acidic. see the entire environment, the biotic environment of the ocean is going to be affected. So that would be a disaster, because our most of the food systems we get now from the ocean, we have to depend on ocean, and that is going to be affected if the because of the climate change there is a decrease in the pH of the ocean. Why Odisha is prone to cyclonic storms? Yeah, Odisha. Yeah, it is the along the east coast. Maximum number of storms are faced along the Odisha coast as compared to the other three states, Andhra Pradesh or Tamil Nadu and West Bengal. It is there are various regions. One is its geography is also important. As you can see, I showed you in one of this Baleshwar faces the maximum storms. You see, Baleshwar coast, there is a funnel-shaped coast at Baleshwar, which helps in the generation of cyclone. And then there is another region. For a cyclone to generate, we need certain conditions. One of the conditions is the sea surface temperature should be more than 28 degrees centigrade. And the sea surface temperature is more than 28 degrees centigrade north of 15 degree north always, because if you see Bay of Bengal and north of 15 degree north, it is almost covered by fresh water at the surface, because huge freshwater discharge from the Ganges Brahmaputra system, and because of the availability of fresh water at the surface level in the northern Bay of Bengal, so the temperature rise is more. If you compare if you take fresh water and saline water, which will be heated first? The fresh water will be heated first. Okay, boiling point increases with increase in salinity. That is the physics. So you need more heat to boil the saline water. That is why we normally put salt at the end of the cooking. Otherwise, you have to spend more gas for heating the things. So if you have more fresh water in the Bay of Bengal, it is easily heated, and that sea surface temperature is easily attained. That is one of the reasons why you have more cyclones along Odisha coast as compared to the other regions along the east coast. How these changes will affect human life? Which changes? I mean, climate change.
Yes, sir. Related to climate change.
So that I explained you, there are
You
so
have explained,
many
yes.
impacts,
Please.
starting from heat wave related problems like stress, cardiovascular problems because of air pollution, and then climate change induced
Infectious diseases are also.
migration, infectious diseases, and so on and so forth.
Sir, thank you very much, sir, for sparing your valuable time with us and for
Thank
your
you very much.
detailed discussion, sir. Sir, please accept this e-certificate on behalf of
thank
Roland Institute of Pharmaceutical Sciences as a token of
thank you,
appreciation.
thank you very much.
Thank you,
So
sir.
you are
We need
sending
your
this
support
certificate.
and cooperation in
Yeah,
future also,
sure,
sir.
sure. You are sending the certificate in my email, or
Sir, yes, sir. I will send you the certificate.
okay? Thank you. So thank you, the participants. In fact, it would have been more lively had there been no COVID. So you
Yes,
see,
sir.
the
Right.
COVID is a
Right.
big challenge. Probably the challenge is more than the climate change now. So we have to see whether there is any link between COVID and climate change. So
Yes.
that is to be investigated. And I request all the participants to, that is you have to go from usable to applicable, useful applications of your pharmaceutical knowledge to help the people who are now suffering from different climate related diseases. Thank you all. Thank you,
Thank you.
Roland Institute of Pharmaceutical Sciences principals, Dr. Patra, and other
Thank
uh, esteemed colleagues of Roland Institute of Pharmaceutical Sciences for giving me an opportunity to deliver lecture in this AICT sponsored training program. Thank you all.
Thank you, sir. So, dear participant, the next session is at evening 7:30. So, I request all of you to join by 7:30. Thank you, sir. So, the session is coming to an end.